For division of fractions, at this level, I like to use a memory device, copy.flip. As you go up through math and you become more advanced in math, you'll want to learn the proper reasoning behind division of fractions. But for our purposes today, we're just going to learn a memory device called copy.flip. All right, so with that, we are going to, I'm going to write this down, copy.flip. And what this means is we're going to take our fractions from our problem. Now, if they're mixed numbers, we want to turn them into improper fractions, but we want to take those fractions and copy the first one. So that's negative 15/8. We want to change the division symbol now to a dot, which we know as we go up through more advanced math now means multiplication. And we're going to flip the second fraction, which is also called the reciprocal. Reciprocal. And that just means to flip the fraction upside down. So instead of 3/14, we would flip it upside down and it would become 14/3. That's the reciprocal. So we're going to flip that one, 14/3. So copy the first, change the division to a dot or multiplication, and flip the second or the reciprocal. And now since we have a multiplication problem, we can multiply straight across, or if we see some reduction that we can do, some simplifying that we can do ahead of time, I much prefer to work with smaller numbers if I can. And I do notice that I am asked to put this in simplest form, so I'm going to start there. Any numerator can be reduced with any denominator. And so I see that 15 and 3, they share a common factor. They share a factor of 3. So this would be 15 divided by 3 is 5, and 3 divided by 3 is 1. Now I look, my 5 and my 8 do not share a common factor, so I'm finished with the 5. But I can see that 14 and 8, they also share a common factor. That would be 2. If I divide by 2, I have a 7. And over here, I would get a 4. And just verifying one final time, 5 and 4 do not have a common factor. 7 and 4 do not have a common factor. And anytime that I have 1 in the denominator, that's automatically in simplest form. There's nothing more to do there. So now I already know I'm going to be in simplest form because I reduced my fractions up front. And now I can do multiply just straight across. This will become 5 times 7 over 4 times 1, or 35/4. Now, I do want to just double check. That is simplest form, but I also want to double check if I have to put it in fraction or mixed number. And it says that I can do either one. In this case, I would enter 35/4. But if it did require the mixed number here, then I would just think to myself that that fraction bar also means divide. 35 divided by 4. 35 divided by 4. 4 goes into 35. This is kind of the long method, but again, because of the level of math that we're working at, we want to be able to look at this. 4 goes into 35 8 times. That would be 32. And that would leave me with 3 remaining, or 3 out of 4 towards my next whole number. And so if that were the case, we could also write 8 and 3/4. The last thing you're going to want to do is you're just going to want to check to see if you have any negative signs. And one of the things that I like to do is I like to count my negatives. If I have 1 negative, then I know my answer is negative. If I have 2 negatives, I can put them together and then I'll know my answer is positive. 3 negatives, 1, 2, 3, I would know that my final answer would be negative. So as I go through this, I will come back up to the original problem. I can see that I have 1 negative here, so my final answers would both be negative, whether I went with the improper fraction or the mixed number.